Good morning everyone. Let's see next theorem on sequences. Yes, let sequence xn be a sequence of real numbers that converge to x not equal to 0. Then limit 1 upon xn is equal to 1 upon x for xn not equal to 0 for all n belongs to set of natural number n. Okay, so let's see proof. What we have to show that limit 1 upon xn is equal to limit 1 by x means sequence 1 upon xn converges to 1 upon x. Given that sequence xn converges to x where x is not equal to 0. Yes, means what we have to show? We have to show that mod 1 upon xn minus 1 upon x is less than epsilon. That we have to show. Yes, means what we have to show? Take cross multiplication. So you will get x minus xn upon xn into x which is less than epsilon, or we have to show that mod xn minus x. Yes, and mod x is less than epsilon. So they have given in numerator they have given xn converges to x, so we can easily show that xn converges to x means mod xn minus x is less than epsilon. What we have to show that? We have to show that mod xn and mod x is less than epsilon now. Yes, okay, understood that we have to show that mod 1 upon xn minus 1 upon x is less than epsilon to show. Yes, okay, so let's see the proof. For this proof we have to use two inequalities. First inequality is mod of mod a minus mod b, yes, is less than or equal to mod a minus b. This is the first inequality, and we know that distance between 2 points suppose is less than delta, so we can write a minus delta is less than x is less than a plus delta. Yes, that these two inequalities we have to use for this proof. Okay, so see proof. Let we know epsilon is always a arbitrary positive number, real number, be any arbitrary positive real number. Yes, given limit n tends to infinity xn is equal to x, they have given us. Okay, this implies for yes x is not equal to 0, so we can say that mod x is greater than 0 or mod x by 2 is also greater than 0 because they have given x is not equal to 0. Yes, then there exists m1 belongs to n such that use definition of limit of a sequence. Yes, n greater than m1 because we have to take 2 m1 and for m1 for this and m2 for this. Okay, so n greater than m1 implies n greater than m1 implies mod of mod xn minus mod x is less than or equal to mod xn minus x which is less than mod x by 2. Okay, so we can say that we can say that this implies mod x minus mod x by 2 is less than mod xn is less than mod x plus mod x by 2. Yes, or mod x by 2 is less than mod x mod xn. Okay, that is, we can say mod xn is greater than mod x by 2. Okay, mod x by 2. So this implies 1 upon mod xn is less than 2 by mod x. Okay, call this as equation 2. Yes, call this as equation 2, and this is our equation number 1. Equation number 1. Okay, again by equation 1, from equation 1 we can write 1 minute. From equation 1 we can write for epsilon upon mod x square by 2 greater than 0, there exists a m2. There exists a m2 that m2 belongs to set of natural number such that n greater than m2. Apply here definition of limit of a sequence. Mod xn minus x is less than epsilon upon mod x square by 2, because they have given us xn converges to x. Okay, call this as next equation, equation 3. Let m is equal to maximum of m1 m2, then m is a natural number, m is a natural number, and by equation 2 and 3, by equation 2 and 3 we can say that n greater than m, n greater than m. This implies what? 1 upon mod xn is less than 2 upon mod x, and mod xn minus x is less than epsilon mod x square by 2. Call this as equation number 4. Okay, see, call this as equation number 4. So next, consider this step. Now mod 1 upon xn minus 1 upon x is equal to mod xn minus x upon mod xn into mod x. Yes, so which is less than mod xn minus x is less than, from equation 3, from equation 3 you can say that this mod xn minus x is less than epsilon into mod x square by 2. Yes, and into mod 1 upon xn into 1 upon x. So you can write here 2 upon mod x into mod x, because xn converges to x. So which is equal to epsilon mod x square upon 2. Yes, into 2 upon mod x square. So you will get answer epsilon for n greater than m by equation 4. Yes, by equation 4. thus for all epsilon positive there exists a m belongs to n such that n greater than m. This implies mod 1 upon xn minus 1 upon x is less than epsilon. So this implies limit as n tends to infinity 1 upon xn is equal to x. Yes, that we have to prove, and we have shown here. Yes, this is the end of our proof. Thank you.